This would be the video for chapter 6.5, absolute value inequalities. First thing we're going to look at here is the inequality of absolute value of x is less than 3. Means that the distance between x, which is this number here, and 0 is less than 3. That means it's within 3. So if I have a 0 here, then we're looking for numbers that are within 3 units of 0. So that would be everything in between. If we have the absolute value of x is greater than 3, so this one here is opening towards the absolute value, that means we're looking for distances that are greater than 3 from 0. So if I have 0 here in the middle, we go out 3 units, but then we want all the answers that are greater than that amount. Same thing on this side. We go out 3 units, but then we want all the answers greater than. Okay, so we'll take a look at solving absolute value inequalities. This is the general setup for an absolute value. And we have an absolute value that is less than c. And you'll notice here that the absolute value symbol, the inequality symbol is facing away from the absolute value sign. Anytime that you have an inequality that faces away from the absolute value, we're talking about an AND scenario, and we're looking for the overlap. But c still has to be greater than 0. It's a compound inequality, and can be written like that, between. And that would be the example we had up here. Okay, the inequality where the inequality is facing, let me change that color. The inequality is facing the absolute value symbol itself. We have an OR scenario. And remember that OR is really a union, so we're combining all the answers with one with all the answers of the other. And we usually have to write it as 2 separate inequalities using the word OR in between. So it doesn't have to be both, and in many cases it can't be. It can be one or the other. The inequality symbols can be switched with their equivalent counterparts, like you see here. First example, absolute value of x minus 5 is greater than or equal to 7. Notice that this is opening towards the absolute value sign, so that's going to be an OR, which is a union. So we're going to go ahead and write it as x minus 5 is greater than or equal to 7, or x minus 5 is less than or equal to negative 7. And you'll notice that right here, I flipped the sign around compared to this one, and that's because we made this number a negative 7. That's the same thing as timesing by a negative on both sides. So the inequality symbol should change directions. Go ahead and continue solving. X is greater than 7 plus 5 will give you 12. The other side here we have, don't forget the OR, x is less than or equal to negative 7 plus 5 is negative 2. So I'm going to go ahead and put 12, 10, 8, 6, 4, 2, 0, negative 2. And we'll graph this one in blue. X is greater than or equal to 12, so a closed circle. And because it's opening towards the variable, arrow to the right. And we'll do this one in red. And a closed circle above negative 2. And because the inequality is facing away from the variable, that would be arrow to the left. So we're looking for all the numbers that are smaller. So all the answers that are over here are combined with all the answers over here, because the word OR is a lot like a union. So it can be on the right side or the left side. It does not have to be on both sides at the same time. Example number 2, we have a plus 3 on the outside. We still have to isolate the absolute value, so we're going to minus 3 first. So negative 4x minus 5 is less than 6. And you'll notice that the inequality symbol is facing away from the absolute value sign, which means this is a compound inequality that can be written as one statement, like the word and. All right, so we're going to go ahead and solve this. Negative 4x minus 5 is less than 6, and negative 4x minus 5 is greater than negative 6. Don't forget to flip your sign over here because you changed this side to a negative, so it's like multiplying by a negative on both sides of your inequality. Continue solving. Negative 4x is less than 11. X is going to be greater than negative 11/4, and the reason for the switch of the sign here is because we ended up dividing by the negative 4 on both sides. Continue solving the other side. Negative 4x is going to be greater than negative 1. X is then going to be less than positive 1/4. Negative over negative is positive, 1/4 is 4, and again, we had to switch our sign because we ended up dividing by a negative on both sides. Let's put some numbers in there. Be sure to use a calculator when you're crunching these numbers. I'm going to grab a calculator, and we know what the 1/4 is. So we'll call this 0, and that's 1. 1/4 is right about here. And on the left-hand side, we're going to have a negative 11/4, which is about negative 2.75. So 1, 2, 3, and 2 3/4, we'll call that right about there. And we have an open circle on both sides. And this is an AND scenario, which means I should be able to write this as one compound statement. So over here I can write that my x is also less than 1/4. And that is still true. So all I'm looking for is the x values in between those two numbers, and that would be my graph. If you'd like to pause the video for a second before trying number 3, go ahead and do that. First thing we're going to do is add 8 to both sides to solve this. So 3 times 5m minus 6 is less than or equal to 21. Divide both sides by 3. The absolute value of 5m minus 6 is less than or equal to 7. And again, the inequality symbol is facing away from the absolute value, which means I will have an and or an overlap scenario, one compound inequality. So 5m minus 6 is less than or equal to 7, and at the same time 5m minus 6 is greater than or equal to negative 7. Continue solving. 5m is less than or equal to 13. M is less than or equal to 13/5, which I believe is 2.6. We'll figure that when we get to the graph. 5m is greater than or equal to negative 1. M is greater than or equal to negative 1/5. Okay, so m is greater than or equal to negative 1/5. So you can see we can write that as one big compound inequality. Let's call this 0. We'll call that negative 1. Negative 1/5 would be, let's assume, right about here. 13 over 5. Let me just double check that. It's 2.6. 1, 2, 3. So 2.6 is right about here. We have a closed circle based on those symbols there above both. And the m is between them, so we're looking for the overlap, and the overlap would be in between. Example number 4. You're buying a new computer and find 10 models in a store advertisement. The prices are listed as follows. We have a sum there. There must be a reason for that. We want to find the mean of the computer prices. Mean is the average. All right, so we got the sum already on there, so we're going to have to divide that by, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, 10 prices. So 66.40 divided by 10 should give us $640. So that would be the solution to the first part. It says we're willing to pay the mean price with an absolute deviation of at most $100. How many computer prices meet your condition? Well, this is a deviation question. So the price minus the expected value of the price. The expected value would be the average. And we want to pay at most $100 more or less from the mean price. So the $100 is the greater of the two, but we're okay to pay at least $100 or at most $100, so we can put an equal sign there. And the shortcut to solving this is to ask ourselves what price, P, is within $100 of the $640 price. That means $100 over or $100 under. So the quick and easy way to solve your price question here is to do the maximum side, which would be 640 plus 100, 740. And your minimum side, which is 640 minus 100, which would be 540. And that is the range of acceptable values, anywhere from 540 to 740. But they're only asking us how many of the computers are within our price range. So we're looking for the numbers that fit within that range. I'm going to go ahead and circle them. We've got this one here, that one there, that one. 450 is too small, 650 is okay, 725, that one's okay, 825 is too big. So if we count them out, we got 1, 2, 3, 4, 5. We end up having 5 computers meet our condition.